Hello guys, welcome back. This is Trockers. We have a problem on graphs and transformations. It's a ZIMSEC June 2016 paper 1 question. It reads, the function f is defined by f of x is equal to x minus 2 times x plus 3, where x is an element of real numbers. We need to sketch on separate diagrams and we need to show clearly all the intercepts and turning points, right? So for this graph, you're going to see that item 2 to 5, they depend on the first graph. So we have to do it correctly. And remember, when finding the turning points, when finding the intercepts, it crosses the y when x is 0 and it crosses the x when y is 0. And also to find the turning points, we're just going to find the midpoint between these zeros here, then we are good. Okay, guys, without wasting much of the time, let's get the ball rolling. All right, so we have this here. Let me write this down. So we have got our f of x equal to x minus 2 and x plus 3. Remember, we are supposed to sketch this graph, right? So we know that when x is 0, right? When x is 0, right? It's gonna be f of x will be equal to negative 2 by 3, which is negative 6. And when y is 0, right, it means x is equal to 2 or negative 3. So now I have all the pieces that I want. So let me pull up the graph here. Okay, I want to use that graph. All right, so here I will quickly do this. I'm going to make it smaller here, right? I need more space on the y's. Right, there is also one thing that we need to find is the vertex or the turning point. So to find my turning point here, I'm going to add 2 and negative 3, right? So if I say 2 plus negative 3 divided by 2, my vertex is going to be negative 1/2, right? Negative 1/2 here, right? Yes. So at negative 1/2, that's where the turning point is, right? Yeah. So to get the y value for that, it will be negative 1/2 minus 2 times negative 1/2 plus 3. So negative 5 over 2 times 5 over 2. So it will be negative 25 over 4, which is roughly 6.25 or minus 6.25. So now I have all the pieces that I want, right? So I will go ahead and graph this, okay? When x is 0, so I'm going to count 2 boxes, 1, 1, 2. So I've got my 3 here, and I've got what? It's negative 3, sorry. 1, 2. So I've got my negative 3, and I have my 2 here, 1, 2, right? So I've got my negative 3 and my 2. What else do I need? Okay, so normally what I do when I sketch, right, you're in the exam, you know your vertex is below the x-axis, so just go ahead, guys. Just go ahead and do this, right? That's the trick which you can use in the exam. That way, it's much easier. Then you can just put the pieces down. So I have my, okay, just 1 second, sorry. All right, I have more space there. Okay. Something of that sort. Good. Okay, so I know the y-axis. What is important is the y-intercept. The y-intercept there is negative 6, and here, you know, it's negative 25 over 4, and here it's it was negative 1/2, right? Something of that sort. So I have my negative 1/2, I have my negative 3, I have my 2. Then for the first part, we are done, right? We have shown the graph of y equal to f of x. So the other graphs, I'm going to make them much smaller so that they all fit here. Okay, So let me just pull this up a little bit. Okay, so if I okay, cool. Right. So the first part, the second part, we now need to graph y equal to the modulus of that. So for the modulus, which is item 2, guys, this is what you need to do. Right. You don't need to do any magic here. You now have everything down. So you're going to put your -3 there. You've got a -2 there. Right. So you've got this part. You've got that part. So it's going to be like this. Right. So what is important is to put your 6 and you've got a 25/4, but the -1/2 does not change. So this is the modulus function. You need to show this turning point here is very important. Then 25/4, remember it was -25/4. Then when we flip that over the x-axis, remember you only reflect the all the parts, all the segments that are below the x-axis when you're finding the modulus, and you keep everything else that was above, right? So item 2, we are done. We move on to item 3. Item 3, it's f of 2x, right? So y equal to f of 2x. So here, that's a compression over the x-axis. You are going to divide every x coordinate by 2. Right, so you're going to maintain this graph here. You will maintain it as it is. You're going to keep all the pieces as they are. All right. So here, you're going to keep your -6, right? But here, it becomes -1/4. This becomes -3/2. This becomes 1. This remains -25/4. So that's my new graph, right? It has been what? It has been compressed over the x-axis. So we divided every x coordinate by 2, right? Then another part is y equal to, let me put it down here, y equal to f of x minus 1. So here, if it's f of x minus 1, that's a horizontal translation. So I'm shifting the graph 1 unit to the right? Meaning to say, everything that was happening here will now be taking place at what? At 1. So you have to be careful. I want you to just try and put an imaginary line here. Right. Remember, this is now your 1, right? So I need this part. Okay, so the graph will be like this. Okay. Remember, here, it was it was 0, -6, but it's now 1 and -6. So this point is also key. Then I have this was -3, it becomes -2. Then -1/2 here. Sorry, it was this one, right? -1/2, it's now on +1/2, right? So it's now here, it's now on +1/2, and the 25/4, -25/4 remains there. 2 plus 1, it's now 3, right? The y-intercept, when I put the y-intercept there, what's going to be our y-intercept? Let's go back to the question. So going back to the question, when I push that 1 unit there, so it was -1. So it's going to be x minus 3, x plus, no, this is 2, sorry. This is going to be 2. All right. So -2 minus 1, right. Then from there, if I'm to find the y-intercept on x0, it's still -3 times 2, it's 6. Right? Because I just push that 1 unit to the right. So if I subtract this -1, it becomes, so it remains -6. Oh, that's good. All right. So let's go back here. All right, so here it remains -6 as my y-intercept. So I have this here. Now we are moving on to the last part. So the last part of the graph is going to be y equal to -2 f of x, right? So for -2 of f of x, there are two transformations. One is a reflection over the x-axis, and another one it's a vertical stretch with factor 2. So to solve the process of first undergoing the first stretching, then reflecting, just multiply the y coordinate by -2 and keep everything else, right? So my graph is going to be like this, right? Remember, this graph was passing through that. So if I multiply this, right, by -2, it's going to be +12 and 25/2. All right. So I now have +12 and I have 25/2, which is 12.5. Then remember, I have my -3, and remember, I have my 2. So the graph will be like that. The graph will be something like that. And let's not forget our -half. Then, guys, we are done. We have sketched this graph, right? So make sure when we are graphing these functions, you know your transformations very well, and at the same time, pay attention to the turning points and the coordinates for the axis, both for x and y. With that being said, guys, I'm signing out. Later.